everyone, we're going to find intervals on which f is increasing or decreasing. Also find the local max and min values of f. Find the intervals of concavity and inflection points of this function here. So what we're going to do is do the increasing decreasing test. So that means if our derivative of f is positive on the interval, it means it's increasing. If our derivative of f is negative, it's decreasing on the interval. We got to basically find the intervals first. So we're going to take this first derivative, f prime of x, and that's going to give you 4x cubed plus 4x, which equals 4x times x squared minus 1, which equals 4x times x minus 1 times x plus 1. All right, so basically, if you set this to 0, you're going to get x, we don't really need that 4 there, but x equals 0, x equals 1, and x equals negative 1. So what we're going to be doing is looking at a sign test. You put these in order, a negative 1, 0, and 1. So what we're doing is we're looking for an x is less than negative 1, x is in between negative 1 and 0, x is in between 0 and 1, and x is greater than 1. And then that's going to tell us on a graph, if this is the graph x, if it's increasing or decreasing, you know, what's going on with our graph. So I'm going to do a little chart, and I'm going to include those. So we have our intervals. I'm going to have to write small because we have a lot here. So we want to test x less than negative 1, test x is less than negative 1 to 0. What's going on there? And x is in between 0 and 1. And where is x greater than 1? All right. Now, at negative 1, let's look at our equation was 4x. And then we had, I'm just going to use x. The 4 is making it confusing. So I'm going to use x. And then we had x minus 1, x plus 1. Let's put plus minus. And that's where we got our critical values of x equals 0, plus and minus 1. So for this first one, I'm just going to go ahead and put x plus 1, because that's what gave us the negative 1. All right. And then I'm going to put x, because that's what gave us the 0. And then I'm going to put x minus 1, because that's what gave us the 1. And then we're going to see what happens. So we want to put a value in for x is less than negative 1. So let's say we plug in negative 2. Now if I plug in negative 2 into this, I'm going to get a negative. If I plug in negative 2 here, that's going to be a negative. If I plug in negative 2 here, that's a negative. So for our derivative, 3 negatives make a negative. Since this is negative, that means our graph of f is decreasing on the interval negative infinity to negative 1. Decreasing. All right, next one. We want a number between negative 1 and 0. So basically, it's still a negative number. So negative 1 to 0 is going to be a negative number. So if I plug in a negative here, that's going to be negative. A negative here is going to make that a positive. If I put in a negative 1/4 plus 1, that's going to be a positive. And then if I plug a negative into this number, that's still going to be negative. So basically what I have is a positive times two negatives, which is going to be a positive. That means our interval's increasing from -1 to 0. Increasing. All right. Next, we want to plug in a number between 0 and 1/2. So if I plug in 1/2 for x, that's just going to be positive. For this one, if I plug in 1/2, that's positive. If I plug in 1/2 here, that's going to be negative. So two positives make a positive times a negative. That's going to be negative. So it's decreasing on the interval 0 to 1. And that's decreasing. And then for a number bigger than 1, let's just plug in 2. If I plug in 2 for x, I get positive. All of these are going to be positive. So that means that's positive. So for 1 to infinity, that's going to be increasing. Increasing. Now, since we have all that information, we're looking for our max and min. So we're looking at our numbers 0, -1, and 1. Since it's, let's look at the 0. 0 here, it is increasing to decreasing. Increasing to decreasing. If I look at these zeros. So going from increasing or positive to negative, that means it's going to be a local maximum. So f of 0, if you plug in 0 in here, you get 3. That's a local maximum. Now, they're both decrease. It's going from decrease to increase here. And also decrease to increase here. Here's the only place it went from increase, decrease. So decrease to increase, decrease to increase happened at both -1 and 1. Since these are both even exponents, I can plug in just either one of them, plus or minus 1 here. And that gives me 2. But since it's going from decreasing or negative to positive for both of those, that's your local minimum. And again, you could, it doesn't matter if you plug in -1 or +1 because it's going to make it positive there. So that's that part. Now let's do the concavity test. The concavity test is, we're going to see if it's concave upward and downward. If you have up and down, then you're going to have an inflection point. So we're going to take the second derivative and our first derivative, let me write that down, was 4x cubed minus 4x. So our second derivative is going to be 12x minus 4. And we factor that as 4 times 3x, that's a square, 3x squared minus 1 equals 0. So set this to 0. You get 3x squared equals 1. X squared equals 1/3. So x equals plus or minus square root of 1, which is just 1 over square root of 3. So you have plus or minus 1 divided by square root of 3. Now, what I want to look at is the intervals if it's concave up or down. Since we have two possibilities, that means if you're looking at a graph, we're looking from -1 square root of 3, and then 0 is here, and then 1 square root of 3. So what I'm looking for is what's happening when x is less than negative 1/3. What's going, 1 over square root of 3. What's happening when x is in between these two, negative 1 square root of 3 and 1 square root of 3. I'm writing too small. And what's going on when x is greater than 1 divided by square root of 3. So what we notice if we plug it in, and you're going to plug it into this equation. So if you have, let's just see if I can squeeze it in. If I plug in a negative, we're doing f double prime of x is positive. We want to find when it's positive. That means it's concave upward. So if I plug in negative 1 divided by square root of 3, that's going to make this positive. So x has to be less than negative 1 divided by square root of 3. It's also going to happen here. If I plug in a number bigger, then just say I plug in 1. If I plug in 1 in here, that's going to be also going to be positive. So that's going to be x is greater than 1 divided by square root of 3. If I plug in 0, so this is my 0, in between here, if I plug in 0 into this, I get negative. So f double prime of x is negative when x is in between negative 1 divided by square root of 3 and 1 divided by square root of 3. That means these two intervals here, this is going to be concave up, and this one's going to be concave down. So let's write it again on the next page. So we have f double prime of x is positive when x is less than negative 1 divided by square root of 3, and also when x is greater than negative 1 square root of 3. So I just want to write this out. Concave up. And same for here. However, when f double prime of x is negative, that happens on the interval between negative 1 divided by square root of 3 and 1 square root of 3. So you can either write, I was going to write it a different way. And you could write the interval like this if you want. But since it changes on the graph, so since it's changing at each interval, concave up, concave down, concave up, that means you do have an inflection point. So the inflection point happens at plus or minus square root of 3 divided by 3 and f of plus or minus square root of 3 divided by 3. Remember, 1 divided by square root of 3 is the same as square root of 3 divided by 3. And that reduces to, and I'm going to go this way, plus or minus square root of 3 divided by 3 and 22 divided by 9. I just plug this number in, this. And I didn't worry about the plus and minus because both of these are square right there. And that's it. Thank you. Have a nice day. Bye-bye.